if the series fails number 1 of my alternating series test, what do I know about the series?
It diverges.
Diverges, why?
Because the limit as n approaches infinity of a sub n is the nth term test.
Yeah. So if it fails number 1, the series -1 to the n, a sub n, diverges by nth term test. If it passes number 1 and fails number 2, you've probably made a mistake somewhere. Meaning it should have passed some other test before we got to the alternating series test.
So it can fail on number 2.
Right, so I mean, yeah, if it passes 1 and fails 2, we've missed something somewhere in the process. And Monday I'm going to talk about the process. Monday I'm going to give you a flow chart to kind of, where do we go, what do we do? We're going to put it all together Monday. Yes?
So then alternating series, you can't use any other tests. You can only find this one, right?
Well, no, with the alternating series, we would have already used the other test to show that the absolute value diverged.
Oh yeah, for the first thing, yeah.
Right. And then the only way we're going to use the alternating series test is if I check the absolute value of it and then it diverges. Then it's going to be the last thing I use.
We're not going to be doing like what we did for the other ones we've been doing before, where we go through like nth term and ratio and all that. We're not going to be doing that.
Well, you will be with the absolute value of it.
Yeah, but. Oh, okay. Okay.
It's like putting everything.
Right. Okay. Yeah.
Bathroom.
Yeah.
Okay.
One other thing I am going to do with y'all. Do you remember we talked about, there was one part we talked about error?
Just inside the argument series.
Is this what?
Just like including the argument series.
Yeah, this is for alternating series.
This is the remainder.
Right, this is the remainder. Your error, your remainder that we kind of talked about.
Maybe subtract, you find the term after.
So if I have, let's pull from way back. I think we did something where we approximated like sine of 0.1.
Oh, with the after you get the series.
Right. And what we need to know pretty much with when you have an alternating series, your error is whatever that next term is. Is the absolute value of that next term. So let's say if I was approximating sine of 0.1 and I said I want us to use 3 non-zero terms, right? So what is my sine series? Sine is odd, right? So we do 1 minus,
X cubed. X cubed.
right?
Oh,
No,
No, there's no.
there's no 1.
Yeah.
Gosh, Bolt. Well, no, I did that totally on purpose to make sure y'all are paying attention. Good job.
That's it.
So then, sine of 0.1 is going to be 0.1 minus 0.1 cubed over 6 plus 0.1 to the 5th over 120. Okay? If it asked how close am I to the exact value of sine of 0.1, it's going to be whatever my next term is. Well, what's my next term in this series? So my error is going to be less than or equal to 0.1 to the 7th over 7 factorial.
So you know it's less
Because I just told you.
If the term was positive, it would be greater than that.
No, it's always less than. It doesn't matter if it, because it's the absolute value of it. Because think about it, doesn't that make sense? Because that next term, I have an infinite number of terms that I'm subtracting a little bit from it, then adding a little less to it, and then subtracting a little less, and then, so the most I can be off is whatever that next term is. So that would be what, 1, 2, 3, 4, 5, 6. Divided by whatever 7 factorial is. 50, 40, I think, maybe. So just by using 3 terms of that series, I'm pretty stinking close, aren't I? So whenever you see error, think next term. If they ask me for the error, if they ask me for the remainder, another way they'll ask it is they'll say sine of 0.1, the absolute value of sine of 0.1 minus p of 0.1. So that's the exact value minus your polynomial. This is the way AP likes to ask it a lot. Then it's just going to be whatever your next term is. Yes?
Still not getting why it's always less than. Because the fourth term is going to be subtracting, right? So you're going to be.
But remember, you're adding some, subtracting some, adding some, subtracting some, adding some, subtracting some, forever.
What you're adding is getting smaller, isn't it?
Right, but we're saying I am either, whatever this gives me right here, the most I can be off, up or minus of it, is this amount.
Why is it always less?
Because we're saying we don't care if the next term is positive or negative.
You're shooting absolute value.
What?
You're shooting absolute value.
Right, that's what I'm saying. I don't care, when I'm doing a series, I don't care if the next term is positive or negative. I'm just saying I know that that error is going to be less than whatever that next term is. Even if I'm adding it, or even if I'm subtracting it, I know that it's going to be less than whatever that next term is. Because that's the most that I can be off.
I get it.
Does that make sense now? Okay.
It's like that radius.
Right.
Because the next terms are always.
Right, because that next term is going to be the highest amount that I either subtract or add to it. Because if this is a negative number, because this could be a negative number, right?
Yeah.
And so if my remainder is negative, then it wouldn't be greater than. Does that make sense?
Right.
Yes.
This is that part of what they do.
This is your exact value. This is exact minus approximation. So exact minus approximation, that is your error or your remainder. This is still the next term. Now I think I'm done.